in the Canterbury area after last September's earthquake, and that was a straight row of trees. So that's how much the earth moved as a result of what happened last September. Now, of course, we saw yesterday the same sort of thing happened on a slightly smaller scale, but closer to the surface and right in the middle of a town, just 10 kilometres out of the town, hence the destruction that we've seen. So seismically, very interesting. There hasn't been a quake of this sort of magnitude in the Christchurch, Canterbury region for about 10,000 years prior to the last 5 months. So in answer to your original question, this is actually a very stable part of New Zealand, except for the last 5 months when something changed, and this fault line that wasn't even known before last September has so far created about 5,000 earthquakes, earth tremors and major shifts in that period, about 1,000 a month.
God. Now, there's something else we've been hearing a lot about in the coverage, and that is liquefaction. Can you tell us what exactly that is? We've seen the mud and water pouring up through the surface. What is the significance of this, and what is causing it?
Liquefaction is one of these sort of, really interesting sort of natural responses. It's physics in action. Think of it, Richard, a little bit like when you go to a surf beach and you have different parts of the beach, the dry sand towards the car park, if you will, and that's very loose and soft underfoot. Then you get to the tidal zone and you get that well-compressed, slightly damp sand, the stuff that can be really hard, rock hard, the stuff that's easier to run on if you're not wanting to work out your calf muscles. Then, as you actually go into where the water is, you'll suddenly find the sand gets very mushy. It's almost like quicksand. Kids love it. You can make dribble castles with it. That's an example of when you have sand molecules and water molecules in certain densities. Now, when you have a very sandy area, like Christchurch, it's on a floodplain with lots and lots of sediment building up over tens of thousands of years. Add to that the vibration of an earthquake, which makes the sand molecules loosen a little bit, breaking the bonds created by the amount of water that is in the water table. That then allows more water to permeate, and suddenly it all becomes like quicksand. You get all of the water coming from the water table, plus broken water mains and river courses that are around in the area that will all suddenly turn into this goopy sort of flooded stuff that it almost looks like freshly poured concrete that hasn't yet dried and hardened.
So obviously this softer ground then would make the shaking a lot more violent and would undermine the foundations of some of those older buildings. Certainly
it can be a major problem if that's happening around the foundations of a building. In a bigger picture sense, it actually is in some ways better than if the earthquake is happening in solid rock, because it doesn't conduct the vibrations quite as well. It's a bit of a buffer, if you will, against the earthquake. But in the immediate area, it is like being in the middle of a pool of quicksand, and we've seen the results with some of these buildings that have just pancaked on top of one another. It's a contributing factor, certainly, to a lot of that.
Now, this quake wasn't as strong in magnitude as the one in September. So is this an aftershock from that quake, or is it a new quake in itself?
Yes, this is a bit of a semantic argument amongst seismologists at the moment, Richard, as to is this a quake in its own right? You look at it and you say, that's an earthquake. There are, in fact, aftershocks technically happening in places like Bakersfield in California, where there's a major quake in 1952. There are still aftershocks happening from that now. The aftershock sequence can go for half a century or more, technically, but there are some seismologists that say that really is splitting hairs. What we're seeing here, because it was in a different area, it may have even happened on a different fracture point along that fault line, so it's potentially seen as the same thing. But this sequence that has really started last September, that's continued for 5 months at a rate of about 1,000 a month, is likely to continue with lesser and greater extent. We've seen 5 magnitudes, a number of 4 magnitudes this morning as well. This is likely to continue and continue to play on the nerves of the people of Christchurch, who are really having difficulty coming to terms with the fact that what used to be their quiet little city in the south is no longer quiet seismically.
It certainly is going to be a very trying time for